bit about climate change and montane biotas. One of the reasons why I'm interested in this is because well, first of all, I'm an entomologist and I study tiny little flies. And so I really don't have the type of data that many of the people have been talking about before. I study groups that are often 85 to 100% undescribed, and you often 30-35% of the taxa that you find are only known from a single collecting locality. That doesn't necessarily mean that they're restricted in their range, but it just means that they've been very poorly studied. And so I'm going to look at it from a different point of view, looking at climate change and the effects of and their montane biotas generally. All right, the climatic changing vegetation zonation with mountains is a very well-known phenomenon. This was first discussed in detail by Alexander von Humboldt in his explorations. He's quite a remarkable man. I think he actually deserves much more attention. He was in Ecuador and he climbed this Chimborazo, this famous mountain in Ecuador, which at the time was considered to be the highest mountain in the world. And even today, it's still the highest land point in the world because it's on the equator and there's a bulge at the equator, and so therefore it is actually the tallest away from the actual center of the Earth. But he was discussing the change of vegetation as you go up a mountain. And here is a sort of a stylized version of what you might find going from tropical forest. As you go up the mountain, you might go up to temperate deciduous forest, coniferous forest, tundra, and ice and snow up on top. Now, of course, you didn't find these coniferous forests in Ecuador, but there is a general tendency for this, what you actually find going up a mountain is also going to be as you go to the higher latitudes. For example, you go to tropical rainforest near the equator, and as you go further north, you're getting to ice and snow and tundra. So essentially what you have mimicked on a mountain or showing on a mountain is what you find actually in terms of latitudinal variation. Now, global warming is actually predicted to drive many of these montane habitats higher and higher, and some of them will actually become very stressed because the zonation as it moves up will actually cause a contraction of many of these ranges. And we saw examples of this earlier on with Craig Muritz's talk about even faunas, biotas moving up and shifting with the change in these biotas as they move. Now, some taxa may be driven to extinction if there's nowhere to go. Now, one of the things, for example, as another way of approaching this problem is rather than approaching from point of view of individual species is to talk about actual habitats, because the species don't exist in isolation. They're actually part of a community. And so rather than ask, we can actually ask what climatic or what biota communities are threatened by climate change. And one way to look at this is to actually look at the vegetation communities, because these are the basis, these for which in holding the biota at different elevations. For New South Wales, for example, we have this very nice book by David Keith on the vegetation types, and I'm just going to borrow very conveniently from his book to show you some of these habitats that actually might be threatened as a result of climate change, global warming, for example. Now, Australia is a relatively low continent compared to almost every other continent, and its highest point is about 2,200 meters. And so therefore, where many of these alpine, for example, the so-called alpine habitats in Australia are highly restricted. For example, in New South Wales, for example, the alpine herb fields right here. These, of course, are found down in the snowy mountain regions. Another one are montane habitats, which actually, many of them are actually like islands. For example, you have these montane bogs, these sphagnum bogs, which you find scattered around the state. And even like subalpine woodlands, the Snowgum habitat. It's always very interesting to go up on top of Mount Capitar, because as you go from the sort of dry sclerophyll woodland, you get further up into more wet sclerophyll, moist woodland. Actually, right on top of that mountain is a little patch of Snowgum. And so that's actually the type of habitat that could be actually become exterminated or wiped out because of climate change. So you would look at these type of habitats, and you can actually study the fauna, the biotas associated with them, and you will see some interesting patterns. Now, here is as I said, I study tiny little flies, and so I don't have much historical data, but what I do have is collection data. And I can associate these species, for example, with certain habitats. And that's why the importance of these collections, because these collections have been made over time. Oftentimes, they can be made, what I am actually using is sort of like residues from collections that someone made for something else. And so, but they are accumulated in the various museums, for example, the Australian Museum, ANIC, various places like this. And from that, I can gather, in the process of describing them, I can get the ranges and actually see how they are associated with various habitats. Here, for example, is a species I described, brindabellensis, of course, reflecting its occurrence in the Brindabella range. But you'll see that it's actually associated with habitats, except for the Otway Range record here, above 1,000 meters. Many of these are in subalpine woodlands. For example, there's one at Barrington Tops or Cathedral Rocks, the furthest north record that I have, which again are these very high, cold montane swamps. And so one of the things I think we need to make as a priority, finding out about these various habitats, especially these montane habitats, which are potentially most threatened, is documentation of the taxa that are found in these habitats that are threatened. And I would propose that we have cross-taxonomic teams from the museum actually to examine these habitats and to document them. And we can then actually look, and we can use these collections as a baseline to see how these faunas are doing and how they're affected by environmental change. Thank you.